Okay, so this section, the support for 5.1 is actually just going to be all factoring, which I love because it's good, very good practice to do, to be able to do this factoring. A lot of times when people get in the upper math classes, that's what the instructors complain the most about is they can't do the factoring. So this is a great section just to get the factoring practice, okay? The two different kinds of factoring that we're going to be looking at is the kind of factoring that we did in the 5.1 section. It's going to be greatest common factor, and then the ones that have the three terms that start off with the x and x. So those are the two different kinds we're going to do. On number one, you have 8x squared plus 2x. The markers are So if I'm factoring this, okay, one of the clues that it's the greatest common factor is that there's only two terms. Okay, so we're looking for what is in common. So when I look at these two terms, I see they both are divisible by 2. So I can definitely pull out a 2. I also see that they have an x in common. So I'm also going to pull out an x and then put in parentheses what is left. And always to find what is left, whatever you pull out, that's what you divide by. So I'm dividing by 2x and seeing what's left. So here, 8 divided by 2 gives me 4. I had x squared, but I pulled out one of them, so I still have x, plus, look at this one. If you pull out the whole thing, think of it as division. If you divide 2x by 2x, anytime you divide somebody by themselves, you are left with 1, right? 2x over 2x is 1. So that's what that would be in factored form. Okay, I'm going to do number 2 right below this just to show the similarities and the differences. On number 2, you've got b to the 5th plus 8b to the 4th. So on this one, b to the 5th, 8b to the 4th, I don't have any number in common, but I do have b's in common. When you're pulling out a letter, you want to pull out as much as you can, okay, that they both have. So actually what you're doing here between these b's is looking for the smallest exponent. That's telling you how much you can pull out, right? I can pull out b to the 4th because I can pull out a b to the 4th from here and here, right? I can't pull out b to the 5th because this one doesn't have enough to pull out 5 of those, right? It only has 4. So that's why we can pull out b to the 4th, then put in parentheses what is left. I always like to just write it underneath just because it helps me visually see what I'm doing here. I had b to the 5th. I pulled out b to the 4th. I've still got a b there. Plus, here I have b to the 4th and pulled it out. So all I'm left with is that 8. Right, number 3. You have b squared plus 6b plus 5. All right, so this one is to the 3 terms. Now, you would look for something in common. That's what you always look for first, is if any of the terms have something in common to pull out, okay? So since there's nothing in common with all 3 terms, right, because this one doesn't have a b, that means I'm going to go to the 2 parentheses and do b and b for b squared. Numbers that multiply to equal 5. Well, lucky for us, there's only one way to do that, right? 5 times 1 is the only way to do that. And can I use those numbers? Will they also add to 6? Sure, 5 plus 1 is 6. So these are the pair that I use. Now you just have to worry about your signs, right? If I need 5 and 1 to be 6, by adding them together, they're both going to need to be positives. So once you get your signs, it doesn't matter who goes where. right? So I can do +5 and +1. Now, on these problems, we are just factoring. We're not solving, okay? It just wants us to do the factoring. What we do extra in the actual 5.1 section is once we did the factoring, we set them equal to 0 and solved them. We're not doing that here. We are just doing the factoring part of this. So this is your full answer there. All right, number 4. B squared minus 9b plus 14. Again, nothing in common. So it's just b and b for b squared. Numbers that multiply, you're always going to this back number, numbers that multiply to 14. So let's write out our options. 14 and 1, 7 and 2. I'm trying to get a -9 from one of these pairs. So again, a lot of times it's easy to pick out the pair that you're going to use, but then the hard part is figuring out your signs. I can tell I'm not going to be able to use a 14 and a 1 to get a -9, right? Those numbers just aren't going to work. I am going to use a 7 and 2. If I want to add those together and have them add to -9, they're actually both going to have to be negative, right? Which doesn't mess up my positive 14, does it? Because what's -7 times -2? It's still positive 14. I just need them both to be negatives because I need them to add to -9 and not +9. Again, once you get your signs, it doesn't matter who goes where. So a -7 and a -2. All right, number 5. R squared minus 80 minus 2r. Now, on this one, before I can jump to R and R, I notice that something doesn't look right. Right? Because look, aren't these terms, they're flip-flopped, right? After R squared should come your R term. And then your constant always comes at the very end. So I just need to flip-flop these two terms before I start factoring. So I have the R squared. Then I'm going to need the R term, which is -2r. And then the minus 80. So now let's see. Now I can start with the R and R. Now, here's what stinks. I've got to multiply to equal -80. I'm going to worry about that sign in a minute. I need to find all the ways to multiply to equal 80. Unfortunately, there's several, right? 80 times 1, 40 times 2, 3 doesn't go into it, but 4 does. 20 times 4, 5 also does. 5 times 16, 6 doesn't, 7 doesn't, 8 does. 9, 10. So 10's already there. So here's all the ways to multiply to get 80. Now, let's think about our sign situation. If you're multiplying to get negative anything, you're going to have one positive number and one negative number, right? That's how you multiply to get a negative, is with different signs. So you can actually go ahead and put those signs in there, because you know you're going to have a positive times a negative to get -80. It doesn't matter where you put those signs. What is going to matter is the numbers you put with those signs. So I'm going to have to use one of these pairs and add to what? -2. So let's just start crossing some pairs out. Doesn't matter who's positive or negative. I'm not going to get a -2 from 80 and 1. So I know it's not that. 40 and 2, not even close, right? Trying to add to -2. Not even close. Getting closer, 16 and 5 would get me closer, but what about this pair? I have got to give somebody a positive and somebody a negative. If you're trying to end up on the negative side, which that's what this is telling you, I need to end up negative. That's telling me that I need my bigger number to be negative. So if this pair is going to add to -2, I need the 10 to be negative and the 8 to be positive. So let's do our check. Does -10 times +8 give me -80? And it does. Is -10 plus 8 -2? And it is. So here's where it matters where you put the numbers. The negative has to be the 10. So a -10 and a +8. All right, number 6. (3y² minus 24y plus 48. So 3 terms again. But this time, when I'm looking at all 3 of these numbers, I do see something in common. They all do divide by 3. If you have that situation, you've got to pull that out. This one doesn't have a y, so I can't pull out any y because this one doesn't have any to pull out. But 48, 24, and 3 all divide by 3, which actually is going to help us a lot. So if I pull out a 3 and put in parentheses, what is left? So I'll divide them all by 3, and let's see what's left. I pulled the 3 out of here, which took me to y². -24 divided by 3 gives me -8y. +48 divided by 3 is +16. So now look at what's left in here. I need to see if what's left in here will also factor. Luckily for us, when I pulled out that 3, it just turned it to y², which is good. That's what we like because there's only one way to multiply to get y², y and y. I need to multiply to 16. So let's see my options. 16 and 1, 8 and 2, 4 and 4. So let's see. I need to add to -8. So I'm not going to be able to use 16 and 1 or 8 and 2. But look at 4 and 4. I can add those to get -8. I just need them to both be negative, right? -4 and -4. If I add those together, gives me -8. And it doesn't mess up my +16 because a negative times a negative is a positive. So I need -4 in here. And then be careful, the 3 that you pulled out is part of your answer. It just comes down in front of those parentheses. All right, last one, number 7. (t² plus 7t minus 18). All right, nothing's in common. It is t², which means I'm going to jump straight to t and t. Multiplying to get -18. We'll worry about that negative sign in just a second. Let's just write all the ways to get 18. 18 and 1. 9 and 2, 6 and 3. What do you know that you're going to have signs? What's going to multiply to give you a negative every time? You're going to have different signs, right? That's how you multiply to get a negative number, is with different signs. So now I've tried to make my pair add to positive 7. So which one of these pairs looks like it's going to give you a 7? We'll work with the signs in a minute. That's the pair we're going to use, right? 9 and 2. I need it to equal this, since one's going to be positive and one's going to be negative. If I'm going to end up positive, that's telling me that my bigger number needs to be positive this time, right? If you're going to put two numbers together that have different signs and end up positive, your positive better be the bigger number. Positive 9 minus 2, right? That's what's going to give you 7. Multiplies to negative 18, yes. Adds to positive 7, yes. So I need the positive to be 9 and the negative to be 2. Okay, so that is the end of support for 5.1. And I've already changed the due dates in MathLab. I left 8.4 open. It's just that I changed its due date to, I think it's like April 4th or something, the week after spring break. 5.1's due date now is March 21st. Okay, so I changed that in MathLab for you. All right, if there's not any questions, I will see y'all after spring break.
You have a good spring break too.
Thank you, Ernie, to y'all too.
Have a good week.
Thank you.
Bye-bye.